Welcome to AP Chemistry. This is part two. Last time we left off when we were talking about types of substances. Now, if you're following the summary, which I really strongly encourage you to do, you'll see that our next topic is going to be SI units. So that's what I've got on the board right now. SI units. Now, if unless you can measure something, you really can't understand it. And we'll be using measurements a lot in chemistry. So let's get acquainted with a few of them. Now, this SI stands for System International. And indeed, it is international. Everybody follows these units. This is set up really right after the French Revolution. They wanted things to be rational. They didn't like the arbitrariness of measurements. In fact, the first measurement we're going to deal with is length. And the French Revolution said, we're going to make the measure of a length no longer a yard. In fact, a yard used to be the length from a king's nose to the tip of his thumb. And let's see, that's about right. I'm a good king. Okay. But actually, what they did, it says, okay, we're going to make our system of length, our unit of length, the meter. They spelled it M-E-T-R-E, but we've got E-R. And our system of length is going to be, our unit of length is going to be the meter. When they first set it up, it's supposed to be 1/10 millionth of the distance from the equator to the North Pole, but that was tough to measure. So they made a bar about 39 inches long. That would be a meter. And they set up a bar that they measured very accurately that everybody measured things against for hundreds of years. In fact, we have a replica of that bar at the National Institute of Units here in the United States. But now they've changed it to a different standard, which relies on light, wavelengths of light, and how far light travels in a fraction of a second. Now, the official unit is the meter, M, and I'll put that unit out here, just M, lowercase. But you'll never see meters used on an AP chemistry exam. We measure things that are a lot smaller than that. In fact, the unit you're going to see for length in AP chemistry and almost every test will be the nm, the nanometer. And this is a prefix that stands for a number. In this case, a nanometer stands for times 10 to the negative 9, a billionth. So when I say a nanometer, I'm saying 10 to the negative 9 meters, a billionth of a meter. So imagine this just a little bit longer. Usually a meter six divided up into 1,000 lines. Imagine it divided up into 1,000,000 lines and then 1,000th of one of those million lines. That would be a nano, a billionth of this length. And what you're going to find out that we'll be measuring is this. Light. That 405 stands for 405. Whoops. Invisible. Nanometers. 405 times 10 to the negative 9 meters. Prefixes can always be changed into their numbers. In fact, in most of the problems involving length in AP chemistry, you're going to have to change nanometers into times 10 to the negative 9. 409 nanometers, what does that have to do with this? Well, if you could see this light in terms of waves, and it's made out of waves, a single wave of this light would be 405 billionths of a meter. That's the size of blue light.